Liverpool. Planetary Sharpener. This is table of contents and all our parts. Introduction. In this project, we bought a mounted manual pencil sharpener, which has 5 parts. They are connected to each other and transmit forces and moments to each other. The outcome of this project is a free body diagram of the mechanical design, free body diagrams of 5 interconnected parts, the forces and moments that are transmitted through the parts. Planetary Sharpener. The function is to sharpen pencils. The manufacturer is Exacto. The cost is $9.47 and retail is $17.99. You would normally use this inside a classroom, and we bought it off of Amazon. This is a free body diagram for the whole mechanical design. The force we know is the moment, which is how hard we spin the crank, and the reactionary forces are F of x and F of y. This is a table with the parts and the materials and all of its properties.
The first part was the crank for the pencil sharpener. I decided that the plastic on the handle would be polyethylene since it's the most common plastic used in consumer products, and aluminum 1100 for the crank arm since it is a common metal used in consumer products as well. A person pushing on the crank at the end will create a moment that will power the rest of the device. This external force causes reaction forces and moments throughout the system. The device would be mounted to the wall, and we assumed a clockwise moment applied. This is the free body diagram of the crank. The knowns are the distance of the crank arm, the external force applied, and then through multiplying the external force applied on the arm by the distance r of the crank arm, we find the moment that is applied. Our unknown is the reaction moment from the frame due to the moment from the arm.
Mounting frame. Mounting frame is what connects all the pieces together. It connects the crank to the helical cutters and the helical cutter frame, as well as holding the receptacle in place. It also allows us to mount the whole device on the wall if we choose to. And the material I chose for the mounting frame is aluminum 1100. The free body diagram of the mounting frame, it has 1 known and 3 unknowns. The known is a reaction force from the handle, while there are 3 unknowns, these being the reaction forces from the helical cutters and the force from the helical cutter frame, which are reacting to the force from the handle. We also have all the forces from the screws to the wall or wherever we choose to mount it to.
For the helical cutter frame, we chose the material to be gray cast iron since it was stated that it was die casted on the product's website. The function of this part is to hold the helical cutters in place to sharpen the pencil. The knowns for the helical cutter frame is that it has a moment coming from the crank, and the unknowns are the reactions from the rods inside the helical cutters.
Next is the helical cutters, which function is to sharpen the pencils. The material of this component, as stated on the product's box, is hardened steel, AISI 304 steel. The free body diagram illustrates the reaction forces between the blades and the rod. Also, the distributed load that the pencil would create and the moment created by the contact between the helical cutter frame and the blades. For this free body diagram, our only unknown will be the reaction force to the pencil.
The receptacle. The function is put pencils through, hides the blades inside, as well as catches the shavings from the pencil. The materials, we chose aluminum 1100 because it is the most commonly used. We assumed it was aluminum from feeling it, and as for the nickel coating, I got that from the company website. In conclusion, we started from the unknown external force on the crank, and used the corresponding reaction moments and forces to determine the final output force that would be applied to the pencil. We had a challenge trying to figure out the reaction forces on the helical blades and its frame, since the load would be distributed instead of a one-dimensional force. Determining the moments and forces were only hard for the center frame and the helical blade.